everyone, welcome to my channel PHYT. So today we're going to discuss about graph plotting. It is one of the most basic and important thing that comes in our board in our throughout study of physics and also in our iit-jee or Neet. So let's begin with graph plotting. I would request you to watch the video till the end because I would not like you to go out of the video with half-hearted information. That's the most dangerous thing. So let's move on. So for graph plotting, 5 basic tips we should keep in our mind. They are: so it comprises of two coordinate axes that can be designated by any variable, any set of variables that can be x, y, xt, vt, etc. As we go on our further study in physics within our course, we will find there are various type of graphs. Then the variation distribution should be uniform along any axis. The variation of the values on our axis that will be shown in the graph. The nature of any graph can be predicted by the combination of coordinates that fit the general equation of the curve. Combination of coordinates, it seems like the locus of the points or the coordinate that fits in the general equation, and we can predict the nature of the graph. Then depending on the domain and range for the function, we should plot the graph, and proper labeling of each axis and title should be given for graph. So let's first see what is domain and codomain. Let us consider a set of variables, maybe real variables x, that is the domain, and now we apply it on function fx. So we gonna obtain some sort of result, and the result will be confined in another domain that is named as codomain, and the results are designated as the range, or the image value of x are designated as range of x variables. Now I show you up with an example. Like a domain comprises of a set of numbers, and now we show you another codomain which comprises of another set of numbers, and range are also a set of numbers which are part of codomain. So this is just a simple numerical example for the study of domain, codomain or range that gives us idea how they are necessary for graph plotting. Still, I am going to explain it within the video how these are much more necessary for a graph. So I provide you with a question below just to guess the function that relates between the domain and the range. Now let's begin with graph plotting. So now how to draw a graph? As you can see here, to draw a graph initially we require two axes, one x-axis that is the horizontal axis and another is y-axis. Both x and y-axis gonna meet at a single point, and that intersection point will be designated as origin. The origin may start from 0, 0, that is the coordinate that we considered for our origin, but we are free of our choices. We should not be restricted to only 0, 0. It can be x, 0, mean any x variable, or it can be 0, y, any y variable on the y-axis, or it can be x, y, any variable, but it should be fixed for any sort of graph we are trying to plot. Now let's see. Only with axis it's not possible, so we require to divide axis on certain value base so that we can designate a point in graph as coordinate. So to do so, we take example of your floor in your room. So you consider your floor as a plane on which we are going to plot the graph. So consider one side of your room as the x-axis and another side of your room, the adjacent side, as your y-axis, and the joining point or the corner of your room as origin. Now you divide the x-axis in equal distribution, that is the uniform distribution, that is in 1, 2, 3, 4, 5, and similarly the y-axis as 1, 2, 3, 4, 5. So now any point within this graph or within this plane or within the floor of your room will be designated as a coordinate. So let's see how to find a coordinate. Now in this graph I give you a point to mark, that is P point with 3, 5 as the designation of the coordinate, where x equals to 3, that's 3 steps along x-axis, and y equals to 5, that is 5 steps along y-axis. So now follow the red dot. It moves 3 steps on x-axis, now 5 steps on y-axis, and it reaches its desired point or the coordinate. Similarly, I'm gonna show about a second coordinate, that is 4 comma minus 5. Now it will be starting from the y-axis first, that is minus 5 step on the y-axis and 4 step on the x-axis, and thus we obtain two coordinates that are p and q, and we join the two coordinates to. So we begin with plot of a graph, and here we have plotted on screen the most simplest form of graph, that is the graph of a straight line. So this straight line can be expressed as a function of x. This is the most simplest function where it carries only single power of x. Here the coordinates has been shown as y equals to x. As you can see, the red line, it shows for 1 comma 1, then it shows for 2 comma 2, it shows for 3 comma 3, 4 comma 4, and rest it goes on. So thus we can express it as a function of x, that is fx equals to x. Now with this straight line we draw, we can obtain the slope of this line. The slope helps in the calculation of the variation or the change of the graph with respect to the variable x or y. Now let's see how to calculate this slope. The slope that is designated as m is the change in y-axis with respect to change in x-axis. So a change in y-axis has been shown with red line, and the change in x-axis has been shown with yellow line. So this red line shows the change in y-axis, that is delta y, and the delta x has been designated with yellow line, that is change in x-axis, and thus we obtain delta y by delta x as the slope. Further we can show that tan theta, if we consider this as a whole triangle comprising this red, yellow and black line as a triangle, right angle triangle, then if this is the theta angle, so then slope is equals to m is equals to theta. So let me write it, so I can show that m is equals to theta. So this must be the theta angle, and this is 90 degrees. So this is the theta angle. So tan theta equals to delta y by delta x. Thus we obtain the slope of a graph. So this is, as I have said, the most simple form of graph. As we advance and study further, we're gonna see such a kind of graph which contains a variety of slopes in a single curve. Now let's study how to find intercept. As you can see here, we have drawn a line which doesn't passes through origin. So thus it cuts the x-axis and y-axis at two different points. Right from the origin, if we measure the distance of that point at which it meets the x-axis is known as intercept in x-axis, defined as a. And similarly for the y-axis, it is defined as intercept in y-axis. If you look into the point closely, you will come to know that for y equals to 0, x equals to 5. This kind of line satisfies that for y equals to 0, x equals to 5. And similarly, there can be another coordinate, or this line will satisfy for x equals to 0, y equals to minus 3. So then how to obtain the equation of this kind of line? That is, earlier like we have done fx equals to x or y equals to x. So how to obtain that kind of equation? It can be obtained with the help of intercept formula, and that is this. As you can see here, as we have obtained that minus 3 is the intercept, so y divided by minus 3 plus x divided by 5, which is the intercept for x-axis, is equals to 1. That is the equation of this line, and further simplifying we can obtain this kind of form. So I'm going to write the equation or the general equation, that will be y divided by b plus x divided by a equals to 1, where A is the intercept for x-axis and B is the intercept for y-axis. I provide you with a question or a part of exercise to follow, like to draw y equals to 3x plus 6. Now let's see. As I've told, that was the most simplest form of a straight line. Now let's make it little complex and keep this x under mod. So fx equals to mod x. For mod x, only positive values of x will be plotted, or fx will be only positive value of x. X can be either positive or negative. So x can be both positive or negative, but y will only be positive, and hence we obtain the plot as in this way. This is only for the positive value of y, and this is only also for the positive value of y, but for the negative value of x. Now let's see another kind of plot, that is fx equals to x square. For this also we're gonna see that x will be both positive or negative, but y is x square. So this is y, that is x square. So for this also we're gonna obtain only positive values, and hence we plot the graph and it seems like this. If you look into the fact, now it's no more a straight line, it's little curve, and the curve comes because as we proceed further we will see that because it is a power of 2 and hence the steepness of the curve has increased, and it will slowly go on changing as we move further on, because the square of the numbers become larger and larger as we move to higher values of number. And same here, like the last graph, that for the positive side of x we obtain the positive value of y, and for the negative side of x we obtain the positive value of y. So at the bottom of the screen a question appears. You try to draw the graph for y square equals to x. It will be little different than the graph that is shown on screen, but still you try. I wish you can do it. Now let's see. As you can see here, three triangles appear along with the graph. These three triangles are used to measure the slope of the graph at three different positions. You can find that the yellow, red and the green triangles, the slope of three triangles, as we move higher, it increases. That shows that continuously the slope of the graph is changing, it is increasing. So this kind of graph is a variable slope graph. Last graph that we have studied was a straight line graph, and hence it has a single slope. But as I have told you that I am going to show you about the variable slope graph. So this is the first basic example of variable slope graph, and later on we will see many other graphs. Now let's move to next graph. You can see on the screen the function state as fx equals to x cube. So hence the graph plot looks like this. So as you can see, as the value increases the graph goes steeper and higher. And next I will present you with the graph x to the power 5. You can see this red colored graph is much more steeper than the x cube. So a question now appears at the bottom of the screen to draw graph for y equals to x to the power 4. Now let's compare the x cube graph and the x to the power 5 graph. Let me show you. So this is the x cube graph and this is x to the power 5 graph. So as you know, for same value of x, when we place the value in x cube compared to the value in x to the power 5, the value of x to the power 5 will be much more. So for the second graph, x to the power 5 value will be more than x to the power cube, and hence the graph goes steeper and higher. Now a note is shown on the screen, that is about even function and odd function. So what is even function? As we have done graph for cases x square, or as I have asked you to plot x4, or you have already plotted the graph of mod x. This kind of functions, right? This kind of function provide us with only positive value of fx. How? Right, for mod x, if we place plus minus value, we're gonna obtain the plus value. Similarly for x square, similarly for x to the power 4. So this kind of functions are known as even functions. And now, right, for the cases of x cube, x to the power 5, or only x, if we place plus minus value, then fx will also be plus minus. This shows that this kind of graph is a graph of odd function. Right, for f minus of x value, we're going to obtain equals to minus of fx. So this kind of graph is an odd function graph. And you can see also that the shape of the graph changes, right, for the odd and even function. But for the odd function graph, it comprises of a positive value side and the negative value side that goes down bottom into the graph. So for any type of graph, if it goes on the upper level of x-axis and the bottom level of x-axis, then it must be an odd function graph. But for an even function graph, it will always stick to the upper level of x-axis when the function is stated in this kind of form. So this will be the best and the simple way to judge any function, either it will be a even or an odd function graph. So next, I show you with a rational function. So what is a rational number? First, let me tell you what is a rational number. Let p by q be any fractional number where q must be not equals to 0. So this kind of number is defined as a rational number. So here the function is also same, where fx equals to 1 by x, where x must be not equals to 0. So this is a rational function. So this is just the basic graph of rational function, and hence we plot the graph. As you can see here, right, for the positive value of x, this is the for the positive value of x. So when the value of x is small, the graph shows a very high value, and as the value of x slowly increases, the graph shows a very low value, right, for the y-axis. And similarly, this appears for the negative value of x, right? For small negative value, it shows a higher value on the negative side, and similarly a lesser value on the negative side for higher value of minus x. Now I present you with another kind of graph that will be fx equals to 1 by x square, and this graph shows like this. Now as I have said, if it is an even function, the graph will always try to stick on the above surface of the x-axis, and similarly this occurs here. Only little the shape of the graph changes depending on the function will be an even or odd, and rather than that the shape remains same. Now at the bottom of the screen an exercise appears. Try to draw the graph for 1 by x cube and 1 by x to the power 4. So right at the start of the video, I told you about domain of a function. So can you find the domain of a function of this kind of function? You will see right from the graph that near the value of x equals to 0, no point exists. This shows that the domain will exclude 0, because at 0 the graph goes to infinity or it deviates, and hence right from the domain it will be having a domain of real numbers, which can be, or rather an integer, because it can comprise of both the positive and negative number, but it will exclude 0 because it is impossible to plot any point at x equals to 0. Now I'm going to show you only a single function or a single irrational function. Why it is irrational? Because at x equals to negative value it has no existence, because under root no real values exist, only imaginary value is possible. So the graph shows us like this. So I will request you to take or draw the image of this kind of graph, because it might be essential or come as an important question in your competitive exams or in various part of your physics proofs. So before beginning with trigonometric functions, I know you are much aware of the term like sine theta, cosine theta, sec theta, cosec theta, tan theta. You have done those things in class 10. So let me first show you what are the things you know about sine theta and cos theta. These are some kind of trigonometric functions which varies with the angle, and you know about these basic values that are being shown on screen. So you know about that at 0 degree sine theta is 0, then at 90 degree sine theta is 1, and these things are known to you. But only with this amount of data is not sufficient to draw a complete set of sine function or cos function graph. So I am going to present you with another set of data that will let us draw rather the second half of the graph, and with which we can continuously draw the continuous sine theta or cosine theta graph. So the second part of the data, I will ask you to verify this data by rather calculating by yourself. So after that, let's see how the graph begins. So before that, we should keep in mind here the x-axis will be mentioned in form of angle, degree, and y-axis in form of real number. So let's begin with the graph. So the x-axis will be the theta axis, and these are the points depending on the values of this screen that are shown. So as you can see here, pi by 6 denotes the 30 degree, 0 as the 0, pi by 4 as the 45 degree, and so on we go up to pi. And rather the second half that has been drawn with the further continuation of the another set of variables on the next up to 360 degree or 2 pi. So here we mention 2 pi. Now after that, let us draw the cos function. Now the cos function begins, and we start drawing right again from 30 degree, 45 degree, 60 degree, and just joining down the points we obtain this kind of graph. I would ask you first to not consider this part of the graph, only to consider right next from 0. So as you can see, at 0 the value of cos function is 1, and it does so, and at 180 degree, that is pi, the cos function shows a value of -1. So here 1 -1. So thus right from here the function starts and ends at pi. But as we further continue, this continuation goes on and on. So it is a continuous function. So next it is shown in dotted line just to show that it is a continuous function. And similar. So now we plot sine function over the cos function just to determine how both the sine and cos function looks at a time, and also to find the intersection point between the cos and the sine function. So as you can see here, here are two intersection points, right here, another is here, and hence if we further proceed we can further find other intersection points also. So the first intersection point is obtained at the 45 degree, and the next intersection point will be obtaining at 135 plus 90, it will be around 225 degree. Now I wish here you can guess the domain and the range of this kind of function. So the domain for this sine or cos function will be any positive or negative value of x that must be in degree, and the range will be from plus to -1. As you can see here, the values varies from +1 to -1. So the range will be from +1 to -1, and the domain will be plus minus value of x. So finally, I appear with the cosec function. So cosec function is the reverse of the sine function. And I wish you also know about this kind of table, what the cosec function values had been given here. So as you can see on the graph, I have initially written down all the essential points that will be needed to plot this cosec function graph. So let's start plotting. So as you can see, I have initially mentioned all the initial values, and thus the graph shows us like this. So as you can see here, right at the angle 0 degree it is infinity, and similarly at angle 180 degree, that is pi, it goes to infinity. So the shape of the graph is much like a parabola. It is a parabolic nature, right, in the part from 0 to 180 degree, and similarly the pattern repeats after from pi to 2 pi, but in the opposite side, rather in the other direction, because from 0 to pi it lies in first and second quadrant value, so it will be all positive value or sine section positive value, and right from pi to 2 pi it is under cos tan section and cos section, so it will be in negative region. And now let us overlap this function with the sine function graph. So this will help you to compare how the sine function goes right from 0 to 2 pi and how the cosec function goes from 0 to 2 pi. So now at the corner of the screen a question will appear. So as a part of exercise, now you have to try to draw sec theta graph. If you find, so finally I bring you up with the logarithmic and exponential function graph. So on the left hand side you will see the log function of graph, and on the right hand side you will find the exponential function of graph. The left hand side, that is the log function of graph, comprises of base as e, and thus the inverse of this kind of graph will be the right hand side graph, that is the exponential graph, with e value as 2.718. At the bottom of the screen an exercise part appears to draw e to the power minus x graph. So till now all those graphs we have done along with all the exercise graphs are enough or sufficiently enough to complete the course of your class 11 and 12. These are all the necessary graphs that will be possibly come throughout the course of class 11 and 12 physics. But still this is not the complete set, because 2D body graph or 2D body general equations are still present that will be discussed in further next videos. Thank you.